Okay, hello everyone. I hope everyone is doing great. So today we're gonna explain and we're gonna learn how we are gonna use Revman. So in here I have several studies regarding one basically one study, but we have or one topic which about IVF and pregnancy and the difference between the scratch of the endometrium and the no scratch on the endometrium in order to do the IVF and then checked for the clinical pregnancy. So basically in here I do have several studies that were included in my in the study or in the topic we are discussing for. I'm going to use it as an example. So basically we're going to use an example in here and the other side, which is this one. So basically this one is going to be your this one is the Revman. The Revman is usually a program that you usually use in order to do your statistics and analysis, in order to have your meta-analysis. The main thing in the Revmans are the studies and the figures. So basically, in here, in order to have a good statistics and a good meta-analysis, basically you need to follow several steps. So basically, this is Revman. In order to open a new window in Revman, it works as the end node. So basically, you just click on files and then you have to click on new and then you open a new window. Yes. So basically, now we're gonna start. We're gonna discuss a bit. So the pages which is gonna open Revman is this one. Here we're gonna discuss a bit about the steps we have to follow in order to have studies in Revman. We're going to speak a bit about heterogeneity as well and how to delete heterogeneity. What is heterogeneity and what is the and how we can know that the study is heterogeneous and how we can deal with heterogeneity. So basically, there are a few steps here I want you to learn. Okay, before everything, so there are several steps here I want you to learn, and these steps are, so I'm going to write it in here so you can memorize it. You can write it aside when you listen to this audio. So basically, in order to have the Revman, steps for Revman, okay, so basically, the first step is to check your included study. So basically to check your included studies. As some studies, basically if you are studying an outcome, some studies they don't have this outcome, some studies they have this outcome. So you have to include the study with which have this outcome. Then comparison. Here you have to do the comparison. Basically included study means comparison. So just you have to do in comparison. Okay. Number 3 is the outcome. Your outcome in here, you need to specify outcomes. In here, you need to specify what is is it dichotomous or continuous data? Okay, so dichotomous or continuous data. Okay, and to be honest, here there is something you need to understand, that not all study or not all the outcome are usually mentioned in all studies. So basically, some studies that you are looking for pregnancy rate or you are looking for clinical pregnancy. Example, 2 out of 3 studies they are including this this outcome. The other 2 studies they don't include this outcome. So basically, you need just to include the study that actually have the outcome. Include only the studies that have this outcomes. Okay, this outcome. Then okay, then the fourth one is you have to put the study inside of the outcome. So after you specify your outcome, you need to put the studies inside of this outcome, inside of this outcome or this outcome. Okay, then you need to specify your direction of the figure. And here we're going to speak about as well about the direction of your figure, of the figure. Then number 6, you need to check for your heterogeneity. Heterogeneity. Then you have the model. So in here you have several steps, or you have several things you need to look at in order to check for your heterogeneity. So basically you have your heterogeneity, then you have the model, then you have a thing which is called leave out test. Then there is something called subgroup. Groups analysis. And then you have your figure. And then the last one is your publication figure. Okay, and in here we're going to speak about all of these ones, about your publication figure, about the model, about the leave out test, about everything. So basically these are the steps you need to follow and you need to learn about when you are doing your data, or when you are doing your analysis. Okay, let's go back to Revman. So in here we have to know, we have to start basically to put our studies. So, and here, if you look at this one, you have main text, explain, etc., etc. Then you go to study and references. So if you click on study and references, you have summary of findings table, add additional tables, references to study. So in here, you have included study. You have to click on right click in order to include your study. So basically, you have to add study. When you add your study, you have here your study ID. So your study ID, for example, it depends on the type of the study or depend on the title of the study. Here, for example, let's go for this one. Okay, this one, let's do copy for the first one, and then let's say paste. Okay, without this number in the beginning. Okay, so and then you click on next. Publish data on unpublished data, just click on next. You just click on next. Next, you don't change anything. Okay, just click on next and then you have finished. Okay, you have included your study. Then you have to include another study. So you have to add as well, add in your study. And then let's take this one, which is Baum et al. Okay, and then you have to add them one by one. This is the issue. In here, you have to add them by one. So you take off the number, then you do next, 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 and then you do finish. Okay, so you added in here 2 studies. Then you need to add, let's say we're gonna add 4 studies. Okay, add study. I'm gonna take this one. I'm gonna do copy, and then I'm gonna do paste. Obviously, I'm gonna erase the number in here, and then I do finish. Okay, and then the last one, I'm gonna add 4 studies for this one. Just an example. However, you need to add all the studies that are associated with this outcome or are explaining about this outcome. So 1 second. So this is here. So I'm gonna add this one, which is France et al. Okay. Then next, 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 and finish. So basically you've added 3 or you've added 4 studies. Now you have to go to add your comparison. Okay, so here if you look at this one, you have studies and references. Now you have to go to data and analysis. You just have to add your comparison. The name of the comparison, for example, let's say your not the outcome, just put in case next. Okay, you have added a comparison in here. You don't have to add the name for this one. Then for this one, you have to add your outcome. So you have one comparison and then you have to add the outcome. The outcome, if you look at this one 1 second. If you looked at this one in here, this one, I'm going to talk about clinical pregnancy. So clinical pregnancy is your first outcome. If you look at your first outcome is in the form of dichotomous data because it does not have a rational number. And as I told you, it's dichotomous, not continuous data. Continuous data, and here your question will be how many clinical pregnancy have happened. It's a dichotomous data because you have, sorry, it's not about how, it's a dichotomous because you have event and total, When you whenever you have event and total, so it's basically, it's a dichotomous data. So you have dichotomous data, not continuous data. You have just to click on next. The name of the outcome, and here the name of the outcome is clinical pregnancy. So I have to copy. You have to go on paste, okay? And then for the group 1, your experiment was, I think it was endometrial scratch, while the second one was no endometrial scratch, as far as I remember from the study. So basically, our group is experimental. Our first group is experimental. So basically here I'm gonna click because I do remember the study. So I'm gonna say is experimental as endometrial scratch. Sorry. scratch. While this one, the control group was no endometrial scratch. Okay, no scratch, and then you put next. Sorry, in here it is known as risk ratio because it is a randomized clinical trial. So you have it's a risk ratio, and then you have to put next, and then next. And then here you just leave it the way it is. I'm gonna explain here later about the graphs, about how the figure is gonna be directed. There is a left graph, is that really the experimental, and is the right graph is really the control. So basically, just leave it as it is. So left graph here, they're saying the experiment. So I'm gonna say endometrial scratch. Okay, because this was the experiment, or what this was the intervention, endometrial scratch. Okay, and here it is gonna be the no endo. No endometrial scratch, and then you have to put, you just have to finish, okay? And then edit a new outcome, just for put next, okay? And here you have this table. So now we're gonna fill in this table. Okay, 1 second. One second, let me. Okay. I made it so big. 1 second. Okay, so basically I have included 4 studies, okay? Now, what is it? Now, how you want to add these ones. So basically, if I'm looking at the clinical pregnancy, I have 1, 2, 3, and 4 here. So basically, these four studies, 1 second, these 4 studies, they have the outcome. So I need first of all to include my 4 studies, okay? So if I want to include my 4 study, there is this one. I want to include this one. In order to do this one, so I need to select them all, okay? So, and I do finish. So I have all my studies in here selected. After selecting these studies, I need to copy paste what I have, copy and paste, sorry. So basically I did have here everything, okay? So after having this one in here, let me adjust this one because it's not being adjusted and everything is being, okay, they like this one, okay. Okay. So basically in here, you have something called, you have included now your studies, and then you have your risk ratio at the end. So they calculated your risk ratio, and then they calculated your heterogeneity, which is here. How much was your heterogeneity? Your heterogeneity was um, 3 square, which is 3.31. Okay, so basically the P is 0.35. And here as well, you can check for your significant, or if it's not significant. So basically, before completing this part, let me just, okay, make it smaller, not that small. Okay, so in here you have now this figure in here. So basically you need to look at this figure. Whenever you have this figure in here, if you look at this figure, you have here something called so this part, okay, you have this line and then you have this part. You need to leave this. So basically this part cannot be seen. Okay, so basically you need to change it. So in order to have your study, okay, basically because in case it was like this, so basically there is a study here is missing. These things in here, this square, this square, are usually for studies, and this square is for study. So here you don't have a square for the second study. The square is missed in here. In order to have this square, so basically you need just to adjust it, and then you have the square that you can see now. Okay, you have your square is t. Okay, so basically here I want you to understand now something which is really important. We are gonna talk about the figure, the direction of the figures. Okay, for your direction, or for the direction of the figure, in order to know about the direction of the figure, your direction of the figure is usually associated with the intervention and with your control. In order to check the direction of the figure, basically as doctors or as a researcher, you need to look at this type. Okay, you need to look at this one. So basically you have the intervention here, and then you have the group here. Okay, in your intervention, 2 out of 50 they got pregnant, 1 of 50 they got pregnant. Here 0 they got pregnant, 5 got pregnant. Here 25 out of 53 they got pregnant, and here 28. Here 16 out of 68, and here 23 out of 64. So the numbers are in favor for the control group. So your control group is the one that is usually in favor for your uh, for your outcome. So basically the outcome regarding the non-endometrial scratch or the control group is usually better than the one that is associated with the intervention or with your endometrial scratch. In order to know the direction, so here there is something you need to know. If the outcome is good, so the left label in here would be the placebo in case or there is no intervention. Okay, so basically when your outcome is good, your left graph, when the outcome is good, your left graph supposed to be for your what's it called, supposed to be for your um, ah, um, for the placebo, or for the no intervention. So basically in here, because the outcome is usually in favor the outcome, so basically the studies are here. Okay, so these studies are usually in favor for the no endometrial scratch. We're supposed to usually make it in the opposite side. So the endometrial scratch, no endometrial scratch supposed to be here, and the endometrial scratch supposed to be here. So in here we're gonna adjust it. Okay, there is a way where you can adjust it, either to go back, okay, from the studies and then to adjust it, or here you can just adjust it. Sorry. Mm, let me just adjust it. Where is the sign to adjust? Not this one. Nope, not fixed one. Let me just. Okay, so basically, yes. So basically you have this sign in here, just have to click on this one. And then you have the analysis, the graphs. And here for the left graph, it's gonna be your no endometrial scratch. Okay, your no endometrial scratch, while this one is gonna be your endometrial scratch. You're on, and then you have to click OK, and then you have adjusted in here. So basically there is a rule you need to understand. So when you have when you are looking at your rule, so your rule is usually associated with the following. So the first one is when your outcome is really good, or when your outcome is a positive, or when your outcome is usually really good for the placebo. So basically your placebo, your left graph supposed to be your placebo, while the right graph is your endometrial scratch or your intervention. Anyways, if you look in here, your studies are usually in here. So your studies, and if you look at the data in here, the data is usually in favor of the control group. So basically you need to uh, do the graphs in the opposite side. So basically no endometrial scratch in here, and then you have endometrial scratch, and your figures are usually in favor of this one. Now we're going to speak a bit about the heterogeneity. What is heterogeneity? Your heterogeneity is usually associated with that the studies are usually, they share the same picos. So basically they share the same pico, which means they share the same intervention, they share the same population, they share the same outcome, and everything they share the same. So basically when you don't have the heterogeneity, you have to understand that one of these that one of these studies usually is associated with heterogeneity, or this one of these studies, they don't share the same heterogeneity, or they don't share the same picos, whatever, okay? So basically, there are usually ways to treat your heterogeneity. So basically, your heterogeneity is supposed to be always 35%. And here, if you look at this one, there is usually P, which is usually 0.35, which is usually 35%. Supposed to be usually more than 10%. Whenever P is more than 10%, so usually there is no heterogeneity, is reliable, okay, reliable. When your P is usually less than 10%, so there is usually heterogeneity and it's usually non-reliable. Okay, so basically, in order to treat your heterogeneity, as I told you, there is usually several steps to treat your heterogeneity. The first one is usually your model. What is their model? And then there is usually the model one. Then there is usually leave out test, and then there is usually something called your subgroup analysis. However, in order to check, in order to do the treatment of heterogeneity, so basically the first one and the easiest one is to do the leave one out test. When you are doing your leave one out test, for example, if you unselect one of these ones, so basically if you look at this one here, it's still heterogeneous. It's still heterogeneous. Let's check here. So basically, there is usually. So basically, if we let's imagine if we have only these two ones in here, okay? Let's imagine if I have only these two ones in here. This one is usually non-heterogeneous. So it's usually heterogeneous because it's usually less than 0.35% or 0.35 or 35%. So basically, in order to treat your heterogeneity, always you have to check the leave one out test, and you are allowed only to do it once for one test, okay? One. You cannot do it every time you are treating an outcome. You can do it only once. So you have to do the leave one out test. When you are doing the leave one out test, you can check your heterogeneity. Whenever your heterogeneity is treated, you have to put your old results, and then after treating your heterogeneity, you have to put the new results, and you have to say the heterogeneity was this much, and it was treated by this type of test, which is the leave out one test. Okay, then there is something called model. This model is usually as not the risk ratio, leave it. So basically, you have to treat it with this following. So basically, there is usually here fixed effect, and then you have the random one. In case you have the heterogeneity, you have to treat the model. So the model, you need to change the model in order to check whether it was heterogeneous or the heterogeneous was treated or not treated with this one. Okay. Then the last one in here we're gonna know is about your picture. The picture, which is really essential. So basically, the add figures, when you add the figures, basically we are looking for forest plot, so which is the one for meta-analysis. You have to check this comparison, and then you have to put next, and then you do finish. So basically, this is your plot, or this is the picture at the end you're gonna receive. Okay, that's it. Let's copy two figures. No, yeah, delete figures in here. I'm gonna do yes. So basically, at the end, or whatever at the end you're gonna have is this lovely picture and this picture. So this picture is at the end what you're gonna receive, and that's it. Okay, so basically this is your yep. So basically this is your plot, and this is at the end of the figures you're gonna receive, and that's it. So this is the study, and this is how you use the Revman for one clinical study, or for one the outcome. In here you have the outcome, which is the pregnancy. So basically, if anyone has any questions, please just ask Dr. Raya, and she's free, and then she's gonna ask me back. Okay. I had to record it really fast because I do have several works, and I do have things I need to complete. Basically, I do have papers in front of me, as I do have exams really soon. And I won't be able to do live session. In case anyone has any question regarding this one, they just can send it to me, and you can just refer to me. And regarding the last session as well, if you have any question, just refer to me. I'm just gonna repeat here really fast about the what's it called? About the web plot. Yeah, because I was asked to repeat for web plot. 1 second. let me just for the web plot, 1 second. I'm just opening the things. Let me just. Okay, so basically, you have in here the sorry, you have in here your plot, okay, or your web plot or whatever, and then you have to click on file. You have to load your image. You have to choose your file. Let me choose. Let me check if this one has some files or it has some graphs. I don't know. Do next, next, next. Yep, it has. So basically, I just need to make it bigger. Okay, after do, you need to add your calibration. So it's 2D bar plot, align axis, proceed. Okay, P1 for this one. And let's see, it's here P6. Okay, so basically it is done in a opposite way. Let me adjust this one. Okay, let's just leave it. I'm just gonna do complete. Your P1, let's make 0, and this P2 is usually minus, let's say -7. 1 second. -7, and then just gonna do okay. Then I'm gonna do measurement, default, sorry, data set. I'm gonna add the data, which are basically add multiple data. So default data, I'm gonna rename this one, which is, let me arm1, okay, arm1, rename, and then I'm gonna rename my data set, sorry, number 2, rename. I'm gonna just say arm2, and then I'm gonna do rename. So now I'm gonna add the points for this one. One second. Leave it. I'm just gonna do 1 point for this arm one. So okay, and I'm gonna pick only one in here. And for or I'm just gonna work on arm one, and then okay, because I started from this point, I'm gonna click on this one, and then bar 2, and then here bar 3, which is roughly. So this one is a 3 minus 3. Let's say this one is -3 point something. And let me use a graph that does not, or just leave continue with this graph. And then, okay, after finishing this one, just go to dataset, and then I'll add export all data, download onto CSV. Okay. So I do have this one. As I told you, the first one, this is usually your mean. Okay. Your mean, and this one is your lower limit. Your lower limit in order to have your standard error, not your standard deviation. So let me put in here standard error. Let me put insert and do standard error. Your standard error is your lower limit or minus this one. So B4 minus B3. B4 minus B3. Oh, I need to put equal. Equal. Nope. Nope. Okay. So I did have this one. Okay, in order to check now for the standard error, as I told you, your standard error here I have negativity, so there is usually negative. For your standard error is usually for your standard deviation, standard error times this one radical times the n, which is the number of your total for this group. Let me check the total for this group. The total for this group was 6. So let me open this one. So basically it is 1 second, 0.7 times the radical of 6. Let me just calculate it. 1 second, 0.7 times this one, 6. So basically 1.71, something like this, 1.71. Here it's supposed to be mean minus this one. So this one's supposed to be a positive sign, okay? Because I did the opposite, which is normal. It's okay. Just change the letter, okay? Mean minus lower limits, and then you have this one. So basically 0.7 times this one, and then you have 1.71. And that's at recording the plot, and then you repeat everything the same as it is, okay? So basically, I hope everyone is doing a great, have a great time. And this was the last time we're gonna do the session, or we're gonna do an course together. In case anyone has any question, just honestly let me know through the emails. And I hope everyone will have a great time. I'm gonna stop share it. In case anyone has any question, just let me know. And good luck for everyone.